See, the resistance is to resist the flow of the charges. The symbol of the resistance is R. Okay. Now there
Yeah.
are some factors on which the resistance depends. Okay. So
Okay.
what factors on which the resistance depend? First of all, suppose we have one wire. Suppose I have this wire. So the wire is having the length, right?
Yeah.
The wire is having this cross section that is denoted by A. Okay. So resistance is directly proportional to the length of the wire. Resistance is inversely proportional to the area of cross section. Is that clear to you?
Yeah.
Area of cross section is this. How much this wire is having this area. Is that clear to you? So
Yeah.
if I combine the one and the second one, it will become the R is directly proportional to the L over A. Is that clear to you?
Yeah.
Now this proportional sign is removed by one constant, that is rho. Now what is rho? Rho is the resistivity that we are having. Is that clear to you? Rho stands for the resistivity.
Okay.
Rho stands for the resistivity. So every material is having the resistivity, and the resistivity will remain constant for every material. Suppose we have wire of silver, we have wire of aluminium, we have wire of copper. So each one wire is having its own resistivity, and the resistivity is going to remain the constant throughout. Is that clear to you? It is only the resistance that is going to be different, because it depends upon the length, it depends upon the area of cross section. Tanushree, if we remember, we are having the cables of the phones are very much long. The charging cables of the phones are very much long, but nowadays the charging cable, the length of those charging cables are got reduced, right?
Yeah.
So see, if they reduce the length of the wire, they are going to reduce the resistance, right?
Yeah.
They are going. If they are reducing the length of the wire, they are going to reduce the length. They are reduce. They are reduce. If they are reducing the length, they are reducing the resistance also.
Yeah.
Is that clear to you? So that will be beneficial for us. Is this thing clear to you?
Yeah.
Any doubts so far?
No.
Okay. So this is the formulas that we are having for the resistance, and this is the chart we are having for each material. Suppose silver, copper, aluminium, tungsten, these have their resistivity, and these resistivity will remain same. Is this thing clear to you? Okay, just write this down. Next part is how we can implement this resistance in the circuit.
Okay.
So resistance in the circuit, there are two types of circuits that we can make with this resistance. Okay, if the resistance are joined to each other like this, if this is the circuit and the resistance are joined with each other in this manner, so if the resistance are joined in this manner, we call this as series circuit. Is this thing clear to you?
Yeah.
We call this as series circuit. Now if this resistance is joined like this, then we call it as parallel circuit.
Okay.
We call it as parallel circuit. You can see the current is going like this. Wait a minute. Yeah, the current is going like this, and it will come like this. But in the parallel case, the current is going like this, but at this point the current is going to divide in three lines. Is that clear to you?
Yeah.
And from here the current will combine from these three lines, and after the combination the current will be like this. So at every point the current is different. In the parallel the current will become different. Is this thing clear to you?
Yeah.
But in series, at every point the current will remain same. Is this thing clear to you?
Yeah.
look at these diagrams that we have in NCERT. These are the series circuit and these are the parallel ones. Is this thing clear to you?
Yeah.
Okay. Now see, we have some formula regarding this. So, see, potential difference for the combination of all the three resistors, that is V1, V2, V3, we got V equals to IR. So if we are implementing the V equals to IR, we got this formula for the series circuit. See, I will tell you, in the series circuit, like this is the series circuit we are having. So the total potential will be V1, V2, V3. So the total potential will be V1 plus V2 plus V3. Is that clear to you? According to the Ohm's law, what we are getting is IR. V equals to IR. It will be I, because the current will remain same. So I will remain I. There will be no I1, I2, I3. Is that clear to you?
Yeah.
So if I take common from the right hand side, it will be R1 plus R2 plus R3.
Okay.
So I and I will be cancelled out and the R will become R1 plus R2 plus R3. So this is the formula of the resistance that we are having. Is this thing clear to you?
Yeah.
So in the series circuit, we are having this as resistance formula. This is the derivation in the series circuit. Now comes to the parallel. See here. Now suppose we have this battery and this is the resistance, this is the resistance, and this is the resistance that we are having. Now in the parallel circuit, we are having current equals to, the current will be different, right? I1 plus I2 plus I3. Is this thing clear to you?
Yeah.
See, in the parallel circuit, the potential difference will remain same.
Okay.
So the current will be V by R, V by R1, because the values of resistance can be different, right?
Yeah.
But the potential will remain same because they are connected to only one battery. So we can take V common from the right hand side. So by taking V common from the right hand side, we are going to have 1 by R1 plus 1 by R2 plus 1 by R3. So we can just cancel them out. So 1 by R will become equal to 1 by R1 plus 1 by R2 plus 1 by R3. So in the parallel we got this resistance. So do you understand what are the formulas of the series and the parallel circuits?
Yeah.
In the resistance. Okay. Okay, let's do one numerical.
Okay.
So I am drawing one circuit for you. You need to just tell me the resistance of the full circuit. Okay.
Okay.
Am I audible? Am I visible to you?
Yeah. Yeah.
Okay. Yeah. Now see here we have three resistance. Okay. This is R1, this is R2, and this is R3 we are having. So R2, we are going to solve this. So we can see in the solution that this R2 and R3 are in parallel.
Yeah.
Right?
Yeah.
So if this R2 and R3 in parallel, we can have R23 equals to R2 plus R3. Is that clear to you?
Okay. Yeah.
So 1 by R23 will become 1 by 2 plus 1 by 2. It will become 2 by 2.
Okay.
That will be 1 only. Is that clear to you?
Yeah.
So R23, the formula of R23 will be 1 ohm. This is the
Okay.
symbol that we need to put after finding the resistance. Is that clear to you?
Yeah.
Okay. Now if we compare this R23, these two with R1, can you tell me what it will be?
Uh,
It will be in series or parallel?
Wait, R23 will be in parallel.
See now,
And
this is the R1, right?
yeah.
Now the combination of R2 and 3 will be
Okay, see.
R2, 3.
Yeah.
Is that clear to you?
Yeah.
And we already know what is it. It will be 1 ohm.
Yeah.
So you can see now R23 with respect to 1 will be in series. Is this thing clear to you?
Okay. Yeah.
So if they are in series, we are going to take out R123. What will be R123?
2 and 2 plus 1.
Yeah, so it will be 3. The
3.
answer of R123 will be 3. Is this thing clear to
Okay.
you?
Yeah.
And it out so far?
No.
So if we take out this R123, it will be 1 added 2. That will be 3 ohms.
Okay.
Is that clear to you?
Yeah.
So this will be the final answer. You can just write this down.
Okay.
So this is the concept of resistance that we have done in today's class. Okay?
Okay.
You can just write this down.